Hi, welcome to another video for mathematics. In this video, we're talking about logarithmic functions. This is just an introduction to this concept of logarithmic functions. So let me start off with a question. If I were to give you an option of taking $1 million, would you take it? Or what if I were to give you 1 penny and that would double every day for 30 days? So for example, day 1 you would have 1 penny, day 2 you would have 2, and day 3 you would have 4 pennies, and then day 4 you would have 16 pennies, and then 32, and then 64, and so on and so forth. So would you take $1 million right off the bat, or 1 penny and it doubles every day for 30 days? Well, as it turns out, a pretty good explanation or illustration of exponential functions. Exponential functions are basically values that increase at a dramatic rate. Now, most people would take $1 million right off the bat because, well, $1 million now or 1 penny now. You know, the answer is obvious. But it's not so obvious when you're talking about exponential growth, especially when it's doubling every day. Because at the end of 30 days, you would end up with $5,368,709.12. So, delayed gratification or instant gratification. In this case, as you can see, the math works out for patience. So logarithmics are inverses of exponential functions. Okay, so we've talked about exponential functions in the past, and you've seen those graphs where the line goes up pretty dramatically and very fast. So a logarithmic is simply an inverse of that. So let me just review real quick what an inverse function is. Here you have your slope-intercept form that we're all very familiar with. You have your y equals mx plus b. Well, to find the inverse of a function, you get the y and the x, you reverse the positions, and then you solve for y again. Okay, so I'm just doing a little bit of algebra here to solve for my y once again, and this is what I end up with. Y equals x minus b over m. So at the top is my slope form, and at the bottom is the inverse of that slope form. So as it turns out, here it is a little bit cleaned up for you, and the inverse, of course, is squared off. But as it turns out, finding the inverse of a logarithmic function, which you have on the left, on the left you have an exponential function. Finding its logarithmic or finding its inverse is not as simple as it may look. So mathematicians devised a formula or a method to finding the inverse of a function, of an exponential function, and this is where log comes in. So the way this would read out, it would be log base b of y is x. Log base b of y is x, and that is the inverse function of an exponential function. So these go hand in hand, and they can go back and forth. You can go from an exponential to a logarithmic function to an exponential function. So here again is that graph of an exponential function, y equals 10x. X can be any real number, positive or negative. So the way you would graph the inverse of that function is you would get an asymptote at y equals x, and then you would mirror off of that asymptote. Okay, so the mirror of that exponential function looks exactly like this, and that is the logarithmic function. That's the logarithmic graph of y equals 10x. That's the inverse function. So these are some of the basic properties of logarithms. Now, this video is only dealing with the first two. The last two are called cancellation laws, and I'm going to make a separate video for these two properties. So again, we're only going to be highlighting the first two properties, where you have log base b of 1 is 0, log base b of b equals 1. And again, we're going to be dealing with exponential and logarithmic functions, and I'm going to show you how you can go back and forth on these. Okay, so let's look at this. Log base 3 of 81 is y. It's some number. I can say x, whatever variable you want to use there. So log base 3 of 81 is y. So I want to know, this is not quite as intuitive for us, because we're not used to dealing with logarithms and solving those out mentally. But what we are used to dealing with is exponential functions. So I want to convert this logarithm into an exponential function. So recall that base 3, log base 3, okay, that base 3 is the actual base of my exponent. And then the y, whatever's on the other side of the equal sign, is my exponent. So it'll look something like this. So there's my base. So it helps out in the naming of a logarithm is that you say log base 3. So just keep in mind that the base, that number, that subscript number is the base of the exponential form of the inverse of your logarithm. So log base 3 of 81 is y. And then, of course, like I said, everything on either side of the equation is your exponent. And that equals 81. So now you can do some mental math and you can say, well, what number do I need to put in my y position to get 81? 3 raised to what power gives me 81? So I can do a mental math. The other approach I can do is I can simplify 81, because 81 can also simplify to 3 to the 4th power. And since my bases are equal to each other, going back to my basic properties that I mentioned earlier, because my bases are the same, I can now equal my exponents to each other. So those are equal out, so those can cancel out. Not really cancel out, but I can essentially ignore them, because I know now that those exponents are equal to each other. So y equals 4. All right, let's take a look at another one. You have log base 5 of the square root of 5 is y. Again, my base 5 raised to my y power equals the square root of 5. And another way to write the square root of 5 is 5 raised to the half. And again, I have two bases that are equal to each other, they're the same, so then I can just equal out my two exponents. So it's y equals half. Okay? All right, let's do another one. I believe this is the last one. So I have log base 7 of 1 over 49 equals y. Now this one's a little bit more challenging because I have a fraction, but just work it out the same way. Just stick to the process. So my base is 7, right? My base is 7. And the other way I can write this out, that fraction is 49 happens to be a perfect square of 7, right? So it's 7 squared. So let me go back to let's turn that into the exponent form. So my base is 7 raised to the y power equals 1 over 7 squared. Now, this is not quite, it's not as obvious what this is, but if you remember your rules for exponents in a fraction, I have 1 over 7 squared. If I want to make this into a whole number, okay, I can move my number, my 7 squared, into the numerator position, right? And that's the equivalent, 7 raised to the negative 2 power. That's the equivalent of 1 over 7 squared. So again, I've now got an equation, I've got a function where my bases are the same. So I can now just equal out my two exponents, which is negative 2. Right? So as you can see, I figured out the answer before I even did all this work, right? So, just work it out any which way that you can, and I worked these out to their completion, but you don't have to, because if you realize at this, here, let me back up. If you realize at this step that you can get this, and you realize, okay, y is equal to negative 2, then you can just put your answer there, put your answer down already. You don't have to do all the work that I'm doing necessarily. All right, so again, this was an introduction to logarithmic functions, and I just wanted to show you how a logarithm is the inverse of an exponential function, and you can go back and forth on these and just memorize the properties of logarithms, because they're going to be very helpful in solving the problems that are coming up in the future videos. And it's one of those things that we're going to work out so many of these that hopefully instead of really memorizing them, well, you'll memorize them as a result of, as a byproduct of how many you work out in practice. So Either way, I hope this helped. Good luck in your study.